For problem 13, based off of the information given in the setup, this is how the figure should look, with those being the distances between the antennas in the islands. And so the first thing the problem asks us to do is to solve for the wavelength of the radio wave. To do that, we're going to use the equation wavelength is equal to speed of the wave divided by the frequency. Speed is constant at 3 times 10 to the 8th meters per second. And the frequency is given to us in the problem, and it is 3 times 10 to the 6 hertz. You do the math, and then you get 100 meters. So the wavelength of the radio wave is 100 meters. Next, we are asked to solve for the delta psi. And to do that, the first thing we need to do is find the path difference between the waves. And to go about doing that, we're going to take island A and then find the delta R. To find delta R, we are going to know the distance between A to antenna 1, which is given to us at 1500 meters, and the distance between A to antenna 2, which is 2,350 meters. Delta R is simply the difference between these two. So delta R equals 2,350 meters minus 1,500 meters, and that is then equal to 850 meters for delta R. Next, we are going to use the equation equals 2 pi divided by wavelength times delta R. So in this case, for island A, it will be 2 pi divided by 100 meters, which we found back in part 8, times 850 meters. The units cancel out, and we are left with 17 pi. So that 17 pi is equal to psi 1, and we also need to find psi 2 to figure out the delta psi. To do that, we're going to focus on island B now, and we need to find B to antenna 1 and B to antenna 2. These are both given from before. Island B to antenna 1 is 2,500 meters, and from island B to antenna 2 is 2,150 meters. Again, we're going to find delta R, which is going to be 2,500 meters minus 2,150 meters, and this is going to equal 350 meters. So we're going to go back and use this equation again to get delta big psi, which is equal to 2 pi divided by wavelength times delta R, equal to 2 pi divided by 100 from before times 350, and that's equal to 7 pi. And because we want island 1 and island 2 to have destructive interference, we want it to be an odd number of pi's to cause this destructive interference. And so because there is already an odd number of pi's for both islands, there isn't necessarily there doesn't have to be a change in the values to make the destructive interference, which means that a possible value for delta psi is 0, because even if there's no delta psi added on, they still have destructive interference, which works for the